right, we're back on part 2 of this last video. All right, let f be a function that is differentiable on interval I. If f has an inverse function g, then g is differentiable at any x for which, I'll fill that in last, and here is the relationship. The inverse, the derivative, how do I want to say it best? I figured it out so it would be the plainest, because some books do it in a very confusing way, but I liked your book actually. Here's what I'm going to say. I'm going to say g prime of x, and defined in the problem, g is the inverse function. So we have g prime of x. So we're looking at the derivative, there's the little spot of the inverse function, equals 1 over the derivative of the reciprocal of the derivative of the f function, which is the original function, evaluated at. And here's a little tricky part. So I'm going to draw a little picture. Here's my functions. You don't really have to draw this. But right here, if this function is g, that's the inverse of f, then if they're going to look at this as x and g of x. So if that's the case, what value should I put in here? So remember, if it's xg of x, then the reciprocal on the f function, the original, it's g of x f. G of x x. So I just switched the two like we did with the a and the b. So what would go in here? Would it be x or g of x? Morgan, what do you think?
I'm just going to guess and say x.
Pardon?
X.
This is looking for the inverse of the reciprocal function, which is what we've been doing. It's the reciprocal of the f function evaluated at. We always evaluate our functions for their derivatives at an x. And since this is f, we're going to take that g of x. Alright, so that is why I didn't really want to present this first, because it looks like gobbledygook until you've seen it and you've worked with it enough. Alright, the only thing that has to go in the blank is what would be not allowed to be 0 in this whole expression, Gianni?
What is it, the denominator?
Yeah, so f prime of g of x cannot equal 0. So I really didn't want to put that in there because that's super gobbledygook. But now it's as clear as can be. Try this one and then I'll release you to work on your assignment. Jonathan, is it working? Are we getting a good picture?
Yeah.
Okay. Alright, the last example, and I'll let you try to do it all by your lonesome. And once I put it up, I will write the answer on the board for the video, but don't look at it until you're done. That'll be the best way to conserve time on the video. Alright, here's the example. F of x, it's purple, equals 1/4 x cubed plus x minus 1. I want you to verify that it has an inverse, that's a function, and I want you to find f inverse of a f inverse derivative, so that's a funny notation. A lot of times you see it in parentheses. F inverse, the derivative of the inverse function at a, so that's what you're going to find when a equals 3. Alright, see what you can do with that. Alright.
Can you re-say that in words again?
Alright, here's the original function, and I want you to find the derivative of its inverse function at a equals 3. Alright, is it showing up?
Yeah.
Okay. Alright, you can go ahead and write down. There's kind of a little bit of a pause now. Alright, I'm going to work it out on the board. Please do not look at it, and look up when you're done. All right, you've had a moment to look at it. Let's see if your work looks like mine, at least to some
I
point.
don't know how to find them.
All right. First of all, you took the function and you found its derivative. Any problems there? All right, so you know it's going to be the reciprocal of that, but what value do you use in that reciprocal derivative? That's the trickier part. So you're probably taking the 3 and putting it right there. Is that right?
Yeah.
So we have 3 equals, the derivative was 3/4. Oh no, it has to equal that, not the derivative. So remember, this is going to be the y value in the original function, so the 3 goes there, and you'll say, how in the world do you solve that? And the question, this will come up. In the example I gave, it was kind of easy. We were able to solve that. But what I've noticed, and this is a note from wise old wisdom here, is that the answers are usually x equals 0, x equals 1, x equals 2, 3, 4, or -1, 2, 3, 4. Usually, because it's something that's so difficult to solve, or solving a cubic, we spent like a whole quarter in pre-calculus solving cubics, so it's a long process with many, many steps. They make these doable. So if you are looking, you can actually do trial and error on this one. You can try, note, x equals 1, 2, 3, 4, 0, or -1, -2, -3, -4. So I looked at this, and I knew that there was a 4 here. So I thought, well, what if this was an 8? Do you see how that would be 1/4 times 2 cubed? That whole expression would become a 2. Plus 2 is 4, minus 1 is 3. So I just used my intuition, and I knew the answer is going to be a whole number. It always is. It doesn't have to be, but they are for us, and it's usually a simple number, a low number. So that's how I got this 2. He looks like he's sitting there. He's the hardest part of the whole problem. He looks like an easy guy. He's not. All right. Does that help? All right, I want you to try these now. I want you to switch over to your assignment, and that will be, can you get, if I write it up in this corner, are they going to catch it, Jonathan? If I write it up on that corner,
What?
You have to turn
the
it down.
assignment.
Oh, yeah.
All right, here we go. It is page, page 349, number 1 to 8, I think. No, that's not right, because I remember we did one of them. Let me see. Thought I wrote it down clearly, but I obviously didn't. I might have to look it up. All right, I need a book.
Here's
Anyone?
mine.
349? Which ones represent this? Is it like number 349? That must be the next page. And there you go. Ah, here they are. 71, I think we did that one. Right? So it's 350, 72 to 80, all of them. 350, page 350, numbers 72 to 80. I think we did 71, but as an example. All right. I definitely want you to get some of these under your belt before you leave, just to make sure you're getting this value right here. Okay. That's it, Brendan and Aaron. Hope you all make it to class next time. See you then. Cut.